Hey everybody, how's it going? So today we're going to be working on some AP Physics 1 level kinematic questions. So some basic things we need to know with kinematics, or 1D kinematics at least, is when you're given a graph, sometimes you'll either get the position to time graph, the velocity to time graph, and the acceleration to time graph. With the position to time graph, it's going to give you the position in relation to the time. And then the slope of the position to the time graph is going to give you the velocity at any given moment. And then the velocity time graph, that's going to give you the velocity at any given moment. And the slope of it is going to give you the acceleration for any given moment. And the area between the curve or the line and the x-axis is going to be your total displacement, which is how far an object is from the origin. And then the acceleration graph is going to give you the acceleration of the object over the time period. Sorry about that, 1 second. And that's basically the main things you need to know about when you're given a graph for a kinematics question. So let's get to it. So we'll start with these questions. Questions 1 through 3 relate to two objects that start at x equals 0 and t equals 0 and move in one dimension independently of one another. Graphs of the velocity of each object versus time are shown below. Object A, Object B. Which object is farthest from the origin at t equals 2 seconds? So this is asking us which object has the greater total displacement. It's asking farthest from the origin. And displacement is how far an object is from the origin. And to solve for displacement, remember, we need to find the area under the curve because we have a velocity graph here, a velocity to time graph here. So area under the curve would give us our total displacement. So here we have 1 times 1, and that equals 1. And then here we have, the distance here is 1, times -1, which equals -1. And in order to find that displacement, we just add those, so 1 plus -1 equals 0. So total displacement for object A equals 0. And now for object B, we can't exactly find the total displacement because it's curved, and we could do that with calculus, but we can't do that in AP Physics or just algebra. But since it's always positive, we know that it's going to be greater than 0 because the area under the curve is always positive, or is positive. So that means object B would be farthest from the origin at t equals 2 seconds because its displacement is greater. So object B is our answer here. Now, which object moves with constant non-zero acceleration? So here, a constant non-zero acceleration, the velocity slope would look something like this because it's constantly increasing at a non-zero rate. And then the graph of the acceleration looks something like this because it's constant, which is why it's always at, say, a value 2. And then that's why it's not changing at all. And the slope of this line would be 2. And in this case, none of these objects have a slope of a straight line at the vertical. This has a slight curvature, which is why that's not right. And this one is just not a constant velocity at all, because first the velocity is 1, and then it drops to -1. So the answer here, the constant non-zero acceleration, would be D, neither A or B, or nor B. Now, which object is in its initial position at t equals 2 seconds? Remember, we already found the total displacement for this one, and it's asking for which object is in its initial position. That means the total displacement for the object is 0 because the object went somewhere and is back. It didn't change its distance from its initial position. So the answer here would be A, because we found that its total displacement is 0. Now, here again we have a velocity to time graph. So the area under the curve is going to be the total displacement for that time interval. The graph shows the velocity versus time for an object moving in a straight line. At what time after t equals 0 does the object again pass through its initial position? So we're just going to assume that the object is going to start at 0, right? In order to find where it would pass through its initial position, we need to find the total area under the curve where it equals 0. So we start off with negative 1 over 2 because 1 times 1 divided by 2 equals 1/2. And then here, we need to find where it would equal 1/2. And we can assume that it's probably going to be somewhere in between 1 and 2. We just don't know exactly where, because this is a very similar triangle to that triangle. So we can say that the answer is B. Number 5. A body moving in the positive x direction passes the origin at time t equals 0. Between t equals 0 and 1 second, the body is a constant speed of 24 meters per second. At t equals 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative x direction. The position x of the body at t equals 11 seconds is what? So first, let's take stock of what they've given us, right? So they've given us that the velocity of this object at t equals 0, the initial velocity, equals 24 meters per second. And they've given us that it is doing that between t equals 0 and t equals 1 second. So time equals 1 second. And what we need to do is we need to find the distance of that, because we're looking to find the position of the object at t equals 11 seconds. So in order to do that, we can use the formula distance equals velocity times time. So d equals 24 times 1, which equals 24 meters. So that's our distance after 1 second, right? So just remember that. And then it is said that the body is given a constant acceleration of 6 meters per second in the negative x direction. That means the acceleration is negative 6 meters per second squared, because we're going in the negative x direction. The position x of the body at t equals 11 seconds is what? So what we know is the initial velocity at t equals 1, because we've already started, or it says that. And so we know the initial velocity, Vox, equals 24 meters per second, right? And our time equals 10 seconds for this, because the position of the body is at t equals 11 seconds, and we're starting at 1 second, so 11 minus 1 is 10. And then our acceleration equals negative 6 meters per second squared. And what we're looking for is the position of x at the body t equals 11 seconds. So we're looking for is x. So what we can do is we can use one of our kinematic formulas that College Board has given us. Let me pull that up. Okay. And then here they are. These are the kinematic formulas that College Board has given us. And we need to find the one that doesn't use VF. Or we can solve for VF and then use that to find our x. And let's actually use that. I feel like it'd be a little bit easier in this scenario. So we don't know what our VF is, so we do VF equals 24 minus 6 times 10, right? So 24 minus 60 equals our VF. And then 24 minus 60 is negative 36. So negative 36 equals VF, okay? So we use that, equals negative 36. And now we need to solve for x. So, and then we use this next kinematic formula, which is x equals x initial plus velocity of initial times t plus 1 over t acceleration t squared. So x equals, our initial velocity is 24. Our initial position is 24 plus 24 meters per second times 10 plus 1 over 2 times the acceleration, which is negative 6, times t squared, which is 100. And then we just solve for x here. So 1/2 times negative 6 is negative 3, and then negative 3 times 100 is negative 300. 24 times 10 is 240, plus 24, And then 240 minus 300 is negative 60, plus 24 equals x. And then 24 plus negative 60 is negative 36. And that's what our distance is. And that answer would be C. And then I'm going to erase all of this. 1 second, guys. Oops. Now let's get to work on number 6, all right? So number 6, a diver initially moving horizontally. So horizontally means that there's going to have two components. This is 2D kinematics. So it's going to have two components, the horizontal and the vertical. And at the beginning, the vertical component is always just going to be Voy equals 0. But the Vx is whatever the speed is. So in this case, it's V. And then the only acceleration acting on this object is gravity, unless it's otherwise stated that there's another acceleration, which is usually negative 9.81. With a speed v, dives at the edge of a vertical cliff and lands in the water at a distance d from the base of the cliff. How far from the base of the cliff would the diver have landed if initially been moving horizontally with a speed 2v? Well, because there's a constant acceleration acting on the object, that means velocity and distance are proportional, so our answer is 2d.